Hello everybody. Today I want to go over the homework showing that relative risk is not a symmetric measure of association. So let us start with exposure. And let's make it yes and no. And let's look at got disease. And let's make that yes and no. We'll put totals in here because we'll actually need them for relative risk. And let's call this A, B, C, D, just like we have been doing thus far. And by now you know this is the first row marginal, which is A plus B. This is the second row marginal, which is C plus D. This is the first column marginal, which is A plus C. And this is the second column marginal, which is B plus D. And we have the grand total, which is A plus B plus C plus D. Now, the relative risk is a ratio where we compare the probability of actually getting the disease. So I'll just write this as D for disease. And I'll just write over here, let D equal the event of getting the disease. And of course, E is the event of being exposed. So we're going to make it as easy as possible with symbols just to save us a little bit of writing. So the probability of getting the disease, we're comparing those who are exposed with those who are not exposed. So I'm going to put a little bar over the E. And this little bar is just going to represent not exposed. I'm just trying to save a little writing here, right? I hope you guys can see this little bar, which means not exposed. Some people would actually read this as E bar. You can legitimately read it as E bar, but it's better to say not exposed, right? So, I mean, it makes sense, you know, the relative risk, you know, you're comparing the probability of getting the disease given that you know the subject was exposed or will be exposed compared to the probability of getting the disease given that we know the subject won't be exposed. So this is really what the true relative risk is. And here with these data, this is really the probability of randomly selecting a study subject who did get the disease given that he was exposed compared to the probability of randomly selecting a study subject who got the disease given that he or she had no exposure. So that becomes an estimate or an estimator of, so this is the true relative risk, right? But when we estimate this, statisticians usually put a little hat over this to show that it comes from data. And once we estimate this, we talk about the probability of randomly selecting subjects from a sample. And so now we can actually make a fraction of fractions understanding that this, you know, is an estimate, right?